Hello, welcome to lecture 3, and the topic of this lecture is voltage current characteristics of diode. We had already discussed in our previous class the biasing of the diode, and we know that there is two types of biasing of diode, forward bias and reverse bias. Now I am going to discuss with you the VI characteristics for the forward biasing. When the forward bias voltage is applied across a diode, and in our previous class we have already discussed the forward biasing of the diode, and we know that in forward biasing the anode terminal of the diode is connected with the positive terminal of the DC source, and cathode of the diode is connected with the negative terminal of DC source. And we also know that when a forward biasing is occurred, there is a forward current flow through the diode, and this current is called forward current. In this figure you can see this is a V bias, and this is the external DC voltage, and this is a current limiting resistor, and this is the diode, and this is the ampere meter that indicates the flow of current through the diode, and these are the voltage meter and is connected across to the diode and DC source. The resistor is used to limit in the forward current to a value that will not overheat the diode and cause damage. What happened as the forward bias voltage is increased positively from 0 volt? And this is a question. What will diode behave at 0 voltage? With 0 volt across the diode, there is no forward current, and you can see this is a graph of the forward biasing of the diode, and this is a 0 point. At 0 point, and there is no forward current, and the plot of current onto the y-axis, and the voltage is across the diode on the x-axis. It's denoted with Vf, and this is in milliamperes. So this is a 0 volt. At 0 volt there is no voltage across through the diode, and there is no current flow through the diode. As you gradually increase the forward voltage, the forward current and the voltage across the diode gradually increases, and you can see when you increases the forward voltages, the forward current and the forward voltage across through the diode gradually increases. When the forward bias voltage is increased to a value where the voltage across the diode reaches approximately 0.7 volt. So 0.7 for the silicon. So in this figure you can see this is a point of 0.7 voltage, and this is a knee point, and the question is what is the knee point or knee voltage? And the knee voltage is defined as the voltage at which device current suddenly increases or decreases. So you can see at the knee point the forward current of the diode is increasing rapidly. As you continue to increase the forward voltage bias, the current continues to increase very rapidly, but the voltage across the diode increasing only gradually above 0.7 volt. So you can see when you increasing the forward voltages with the external DC voltage, and at the point of 0.7 the current increasing rapidly, but when you increasing the external DC voltage, you can observe the forward voltages across the diode has a small change, but as compared to current in forward biasing, there is a very small change occurs to the forward bias voltage, and the change in current is very rapidly increasing. So this is the analysis of the forward biasing, and this is the characteristics for the forward biasing diode. This small increase in the diode voltage above the barrier potential is due to voltage drop across the internal resistance of the semiconducting material. So we have already discussed in our previous class when the forward biasing is occurred, and when the current flow through the diode, there is some bulk resistance occurred in the forward biasing. And what is bulk resistance? Again, I repeat it. The bulk resistance actually thus a combination of p-type material and the n-type material resistance, or the summation of p-type material or n-type material is called the bulk resistance. VI characteristic for reverse bias. When a reverse bias voltage is applied across a diode, there is only an extremely small reverse current through the PN junction. In our previous class, we had discussed the reverse biasing, and we know that in reverse biasing there is some small reverse current flow through the diode, and this small reverse current is called the reverse leakage current. So with the 0 volt across the diode, there is no reverse current because the diode behaves like a open circuit. As you gradually increase the reverse bias voltage, there is very small reverse current and the voltage across the diode increases. When the applied bias voltage is increased to a value where the reverse voltage across the diode reaches the breakdown voltage. Actually, in this figure, this is a breakdown value of the voltage, and this point is called a knee voltage or breakdown voltage. So at this point, the reverse current begins to increase rapidly. You can see in the negative y-axis the current increases and the reverse current in microampere. As you continue to increase the bias voltage, the current continues to increase very rapidly, but the voltage across the diode increases very little above VBR. So this is the point of VBR, and when you increase the bias voltage, this you can observe the change of VBR is very small and the change of IR in reverse direction is very large. So this is a VI characteristic for reverse biasing. This is a complete VI characteristic curve. This is a VI characteristic curve for forward biasing, and this is a VI characteristic curve for reverse biasing. And this is a 0.7. Actually, this is a barrier voltages in forward bias, and this is VBR breakdown reverse voltage, and this is a point of knee point, and in forward biasing case, this is a point of knee voltage point. So this is a forward current. Actually, is taken milliamperes, and this is a reverse current. This is in microamperes. This is a forward voltages and this is a reverse voltage. Forward voltage, actually these voltages are in 0 to sometimes 5 voltages, 10 voltage. Actually it depends on the diode rating. And this reverse voltage, actually these values vary. Sometimes its value in 1000 voltages. So this is a complete graph of diode characteristic curve.